All right, so far, you guys, we have displayed categorical data or not quantitative, right? So quantitative is numbers, categories. So when you have categories, you do bar graphs, pie charts, okay? So now we're switching to quantitative data and how you would display quantitative data. So the first thing we're going to talk about is how to make a dot plot. How to make a dot plot. These are very easy graphs that you can use when you want to talk about data and distributions. So, for example, how good was the 2012 U.S. women's soccer team with players like Abby Wambach, Megan Rapinoe, and Hope Solo? The team put on an impressive showing en route to winning the gold medal in the 2012 Olympics in London. Here are some data on the number of goals scored by the team in the 12 months prior to the 2012 Olympics. So the number of goals per game here. So when you make a dot plot, you are going to draw a horizontal axis, as in a number line, and you're going to label it with the variable name. So always title your dot plot underneath. And then you're going to scale the axis. So you kind of want to look at the minimum and the maximum when you scale it. And then you put a dot above the location on the horizontal axis corresponding to each value. So here is a dot plot for the data above. So notice they've got a line, like a number line, and they go from 0 to 14 because they scored anywhere from 0 to 14 goals. And they titled it number of goals scored. And then they correspond, they put a dot for each one, and you build your dots up kind of like that dot plot we did on the first day on the board. So then you can talk about the data. I'll give you guys a minute. All right, and so then we interpret the graph of the quantitative data. And you're going to start doing this. Interpreting distributions is what it's called. And so the acronym you want to remember is SOCS. S-O-C-S. SOCS. Don't forget your socks. Oh. Okay. So what this stands for is shape of the distribution, outliers, potential outliers. We're going to actually figure out how to calculate outliers, but for now you can say this appears to be an outlier just by looking at it. Okay. And then center. The center of the data is like the mean or the median. And the spread we'll calculate eventually. For now, we can just talk about range. So some things to write down next to each of these. For shape, you can talk about single peaked. You can use the words roughly symmetric. We'll talk about what that looks like. Skewed, we're going to talk about the two kinds of skewed, skewed left, skewed right. Clusters, if there's clusters of points. If there's gaps in the data, you can talk about that. That's all shape, okay? And then outliers, you guys know what those are? They're points that are kind of far away from the rest of the data. Center, we've got median and mean. You guys are probably just going to do median to start with because you can actually find the middle dot of the data. For spread, eventually we're going to calculate the standard deviation. IQR, don't worry about that yet, but that is a spread. And range. So range is the one you're going to use today, probably. Data ranges from this to this, and that's the spread. Okay. So anybody have an idea about the shape of the data here? Single peaked, okay? You don't look at any like little miniature bumps in it, just big peaks. For the skewed part, if you just look at this data without these 2 points, then there's more of a tail over here, which means it's skewed left. And we'll talk about that in a little bit. There are clusters of data, right? You could say that most of the data falls between 0 and 5, so there's a cluster of data there. You can say there's a gap between 5 and that next goal right there at 13. And then you have these two. What would we call these 2 points? Yeah. So there appears to be outliers is usually the words we use, appear to be outliers, for those 2 goals, 13 and 14, where they scored a lot. The center. How would you guys find the median given that there are, how many games here, you guys? 1, 2, 3, 25. All right. So there's 25. How can I find the middle point? Which spot is it in? What'd you say? Yeah, the 13th, because then there's 12 on each side, right? So 24, you've got, or if you just divide by 2, it's 12.5, so you have 12 on each side. So there is a middle number in the 13th spot. And you would count from here over. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it falls where there are 3 goals. So the median is 3. Or you can say the center of the data is 3. Meaning, on average, they scored 3 goals a game, right? Or typically they scored 3 goals a game. And spread, you guys would just say the range, and the range is from 0 goals to 14 goals. So here they actually just did all that. We just talked about all that, so I think we're good. We probably don't need to read it. Okay, same thing. So look for major peaks. We already talked about this. Outliers, symmetry, skewness. Okay, so let's talk about what symmetric means, and I would draw some of these pictures. You don't really need to draw them with bars. I'm just showing you it works with bars or dots. How I would draw this for symmetric is just make a curve that looks like that. It does not have to be perfect, like this one is pretty perfect. No data is perfect, so you can say roughly symmetric. Okay. And typically we pick one of these 3. We say roughly symmetric, or we say skewed left or skewed right. It's usually one of those 3. So for the skewed, I wouldn't draw the bars, all right? I would draw a graph that looks like this. So the tail, we call this part the tail, is on the left side. You can also picture this like your left foot. Unless you have weird feet that they're all like uniform toes, most people sort of have like a bigger toe and then smaller toes, and so that's your left foot right there, and so it's skewed left, okay? And then this would be like your right foot, and where the tail is, so there's the tail of the data is on the right-hand side, that's your right foot, so it's skewed right. And I don't know that I would write all the definitions, but I would draw the pictures and label each one. And then this is just called uniform. We don't use that a whole lot if you've got uniform toes that are all the exact same height. Bimodal means that it comes up and back down and up and back down. It has to be pretty obvious to be bimodal, otherwise you say roughly symmetric. And another word for this is unimodal. In other words, there's one peak. Single peaked or unimodal means the same thing. So let's practice it. We've got 2 dot plots for different sets of quantitative data. Describe the distributions. So figure A shows the result of rolling a pair of fair 6-sided dice and finding the sum of the up faces 100 times. So this is A, hard to read. So this right here is A. That's the dice. And B shows the scores on an AP Statistics class final quiz. So here's B. We've got our final quiz. So we have to describe our socks. What does S stand for? Shape. All right, so anybody have a shape for this data? Roughly symmetric. What else about how many peaks? 1 or unimodal. Don't say 2, even though this kind of comes back down, it's not enough, okay? So it has to be real obvious. Cool, what's the O stand for? Outliers. Are there any outliers? No. Not really, okay? C, what's the C stand for? Center. With just guessing by looking, what would you say the center is? 7. If you want to count 50 spots, but I'm going to go with 7. All right, it is probably 7. And what's the last one? S. What's that? Spread. So it goes from what to what? 2 to 12, okay? The lowest number of dots is 2 when you roll 2 dice, and the highest would be 2 sixes, so sum of 12. All right? And B, let's go shape. What do you guys think? Very good. Skewed left. Okay, unimodal. Any outliers? No, it has to be pretty obvious, like those soccer goals. And center of this one, just a guess, what do you think it is? Looks like 90. Again, you could count the middle of all the scores from left to right, and then spread goes from what to what? I think that's a 70. It's hard to read. 70 to 100. 20 would be a pretty rough percentage on the first test. They were nice and good. So here, you guys, is an obvious bimodal, just to show you what that looks like. You might want to draw it on your notes real quick, just a sketch and what it's called. So this clearly has 2 peaks, right? So I just draw that and write bimodal. Unimodal is the 1 peak. Multimodal is after you get past 2. All right. So if you have 3, 1, 2, 3 peaks. I don't think I've ever used that in this book, but just some vocab for you guys. Okay. So this is the data from you guys, both classes, for number of people who live in your household. Okay, so your guys' data. So, Cody, why don't you describe the shape of the distribution? I agree with you. Okay. And Molly, do you have an approximate center for the distribution? I would guess 4. We could count. There were 34 of you guys total, so we would count to 17. 1, 2, 3. Is that 4 dots? 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. All right, so it's in here. Yep, 4. Good job. All right, and let's go spread, Mac. What do you think? 3 to 7. Some of you guys live with 7 people. That's pretty good. And outliers, I would say no. All right, no outliers. Does not appear to be any outliers. Nobody's super outside of the data. There's not somebody over here with like 12. Okay. And that's it for our socks. I feel like we got this. I don't think we need to do this again. This is like the exact same thing. Okay. So now, you guys, we do compare distributions. So that was just doing one distribution. We also compare them. So when you're comparing them, actually that might have been the last example. When comparing them, you have to use words like greater than and less than and about the same as when you're talking about, say, the center, right? So you could say one person's center is larger than the other center of data. So I think that was what that last example was. We've got, we're comparing the number of people that live in a household in South Africa versus the UK. All right? So you would describe the shapes right here. So this guy's skewed right, and this guy's roughly symmetric. Okay, not really a comparison word for that one. For outliers, No outliers here, and this is definitely a potential outlier. This even could be an outlier, but this outlier skews the data. That's what kind of pulls it. All right. And then for the center, again, you could count them. This one's center is like maybe 6, and this one's center is like 4. So you would use words like more than and less than. All right, so the center of the data in South Africa is more than the center in the UK. So typically people in South Africa are living with larger families than in the UK. All right. And spread, you can talk about that as well. This guy has a much larger spread than this distribution. Make sense? So use comparison words when comparing distributions. All right, so that was dot plots. Another way to display data is stem plots. You guys have been doing these for a while now, probably in your lives. Or maybe you don't do them regularly, but you did them a while ago. So how many pairs of shoes does a typical teenager have? To find out, a group of AP statistics students conducted a survey. They selected a random sample of 20 female students, all females. They recorded the number of pairs of shoes. Here is the data. All right, so the steps are to do your stems, to add the leaves, and then to put it in order, and to do a key. So those are the steps. You should just kind of write those down. Stems, add the leaves, then put the leaves in order, and then do a key. So a lot of people forget the key. Don't forget the key. All right. When you do the stems, you would just kind of draw this lovely line. And remember, you split these kind of however you want. This would make the most sense to split it where there's a 5 and then a 0, right? So what's the smallest number or pairs of shoes that a girl owns in this data? 13. And what's the biggest? Okay. 57. So your stems are 1, 2, 3, 4, 5. What if I don't have any data in the 30s? Can I skip it? No. All right, you have to have a number in between. You have to go in order there, so don't skip any stems. All right, and then we just go across our data and fill it in. So I have 50, so that'd be 50. 26, so I'm going to put a 6 here. Another 26, so I'm not going in order yet. 31, so put a 1 here. 57, put a 7 here. 19, so 1, 9. 24, 2, 4. 22, 23, 38. Some of you guys can do this in order on the first time, and that's totally fine if you like to do it that way. 50. I actually find this goes faster, though, usually. 13. Oh, I did that one wrong, you guys. 13. That's a 1, 3. 34. 23. 30. 49. 13. 1, 3. 15. And 51. All right. Then you put it in order, and it does go faster, I really think, if you do it this way. So 1. So now in order, I have to go 3, 3, 5, 9. And then 2 would be 2, 3, 3, 4, 6, 6. And then 3 would be 0, 1, 3, 4, 8. Hopefully I did all right. 49, 50, 50, 51, 57. Make a key. How do you make a key? You just pick a number and you say what it means. That's all you have to do. So I might pick this very first number. You can pick any number you want. And you do a 1 slash a 3. So you have to do it like that. Means 13 pairs of shoes. Okay. So reminders, don't skip any stems, all right? Even if there's nothing in that category, don't skip anything. Arrange the leaves in increasing order from the stem and provide a key that explains the context, okay? This is called a back-to-back stem plot. You are allowed to do these. They work out well when you want to compare data. So this time we've got the female data and the male data. Now, just like the dot plot, you guys, this actually forms a shape with numbers. So you look at it sideways, but you can actually kind of draw a curve. And so that data, if you turn it, is skewed left. Okay? And we have another guy here, skewed right. Okay, don't use stem plots for large sets of data. It just is way too many numbers, all right? There's no magic number of stems because you can like do less or more, but 5 is a good minimum, all right? Too few or too many make it difficult to see the distribution's shape, which you're going to do socks on these. If you split stems, be sure that each stem is assigned an equal number of possible leaves. So just make sure when you split them, it makes sense how you split them. And if you have really big numbers, you guys, like say you're talking about teachers' salaries, this lovely number is too big. Round it to 43,000. Okay, that's what you would do, 43,000. And then you would use 4 as the stem and 3 as the leaf. And you can just say what it means. So you don't have to write out 3,000. You would do 43, and then in your key you would say that means 43,000. Okay, so you're allowed to round numbers. I think we're good. But let's make sure we can understand these. Here's a stem plot of the percent of residents aged 65 or older in the 50 states and the District of Columbia. The stems are whole percentages and the leaves are tenths of a percent. So check out this key. 8/8 means 8.8% of people who are 65 or older. All right. So we'll just see if we can answer these multiple choice questions. So multiple choice number 2. The low outlier is Alaska. What percent of Alaska residents are aged 65 or over? You guys can just say it. Right, it just said the low outlier, so that's that guy, so 6.8%. They want to make sure you can read the key, right? And you get B. All right, ignoring the outlier, the shape of the distribution is. So ignoring this outlier right here, what is the shape of the distribution? What'd you say, Evan? Yep, I would say roughly symmetric. Okay. Ignoring the outlier. And then the center of the distribution is close to. This is where you could count or you could estimate, but you probably have to count, I think, on this one. So there are 50 states. I always look up here and see if it tells you how many numbers, so I don't have to count them. And then you got to go to 25 from left to right in order of least to greatest. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. There are exactly 25 numbers on each side, right? So you have to average the 2 when you have 2 middle numbers. Do you guys remember that from the median? And luckily they're the same anyways, so if you average them, you get 12.8. Everybody good on that? Median? Cool. Go ahead and write that down.